Another method for solving quadratic equations is using the zero product property by factoring. This is a strategy to use when you can't solve by square roots. If you notice, all of these, or none of these, have an x term, so a bx term. If we have x squared and a constant or an expression squared, we can solve using square roots. But if we have ax squared plus bx, we're going to need to try to use the zero product property, or a third strategy, the quadratic formula. So we could not take the square root of both sides of this equation because we don't know how to take the square root of a quadratic trinomial. Instead, we need to write this quadratic trinomial in factored form. Once we have it in factored form, we can use the zero product property. So the factored form of x squared plus 2x minus 8, we're trying to figure out which two numbers multiply to negative 8 but add to 2. A lot of you don't need to use the diamond, but if you do, that's great. So 4 times negative 2 is negative 8. 4 plus negative 2 is positive 2. Again, this diamond is not required if you can do this in your head, but what is required is that you write this equation, x plus 4 times x minus 2 equals 0. You cannot just write the factored expression. It needs to equal 0. If it does not equal 0, we cannot solve the equation. So checking that this factored form equals 0, we know if two factors multiplied together equals 0, if the product is 0, then one or both factors equals 0. That is the zero product property. So if x plus 4 times x minus 2 equals 0, then either x plus 4 equals 0 or x minus 2 equals 0. That allows me to find the solutions to my quadratic equation, x equals negative 4 and x equals 2. If I plug negative 4 into this equation, negative 4 plus 4 gives me 0, and the entire product is 0. If I plug in 2, 2 minus 2 is 0, and the entire product equals 0. I could check it with my original equation. Negative 4 times negative 4 is 16, plus 2 times negative 4. So it's 16 minus 8 is 8, and 8 minus 8 is 0. Check. 2 squared is 4. 4 plus 2 times 2 is 4. 4 plus 4 is 8, and 8 minus 8 is in fact 0. Here's some vocab. The zeros or roots of a function are the x values of the x-intercepts, and that is in fact given by the solutions to this equation. So when x equals negative 4 or x equals 2, those are going to be the x values of my x-intercepts. When I plug in negative 4 into my function, my output is 0. That means y equals 0. When I input 2 into my function, my output is 0. So those are the two values, negative 4 and 2, that when they go into my function, the output is 0, meaning they lie on the x-axis, and they're the zeros or roots of my function. Here's another example where instead of having a quadratic trinomial, I instead have the GCF case. So this particular expression has a GCF of 3x. So I pull out that 3x, and I'm left with x minus 2. I'm still able to use the zero product property here, because if 3x times x minus 2 equals 0, either 3x equals 0 or x minus 2 equals 0. Again, I need to factor the quadratic expression, make sure it equals 0, and then set each of those factors equal to 0 using the zero product property. That means there are two solutions to this quadratic equation, x equals 0 and x equals 2. When I plug in 0, I get 0. 3 times 0, well, 0 squared is 0. 3 times 0 is 0. 0 minus 6 times 0 is 0 minus 0. That does in fact equal 0. And x equals 2. 2 squared is 4. 4 times 3 is 12. And 12 minus 6 times 2, 12 minus 2 is 0. What this tells me is not only that 0 and 2 are the two x values that when I plug them into this equation give me 0, it also tells me that looking at the function f of x equals 3x squared minus 6x, the two x values that give me the x-intercepts are 0 and 2, 0. These two values are the x-intercepts of this function, 3x squared minus 6x.